everybody, and welcome to Talks at Google. My name is Helen Riley, and I'm a leader here at X, Alphabet's Moonshot Factory. And I'm super excited about this talk, being a space enthusiast and actually having just returned from astronaut training at NASA. So I'm thrilled to be welcoming Dr. Moiya McTier to talk about her new book, The Milky Way, an autobiography of our galaxy, detailing what humans have so far discovered about the formation and eventual death of this galaxy we call our home. Moiya will spend about 30 minutes sharing some quotes, insights, perspectives on her research and her book before we move to Q&A. So for those of you on the live stream, please feel free to submit questions, which we will take at the end of Moiya's presentation. And with that, let me introduce our special guest. So Dr. Moiya McTier is an astrophysicist, folklorist, and science communicator based in New York City. After graduating from Harvard as the first person in the school's history to study both astronomy and mythology, Moiya earned her PhD in astrophysics at Columbia University, where she was selected as a National Science Foundation Research Fellow. Moiya has consulted with companies like Disney and PBS on their fictional worlds and helped design exhibits for the New York Hall of Science and given hundreds of talks about science around the globe, including MSNBC, NPR, and others. So to combine her unique set of expertise, Moiya hosts and produces the Exolore podcast that explores fictional world building through the lens of science. And when she's not researching space or imagining new words, Moiya can likely be found watching trashy reality TV with her cat, Cosmo. So thank you so much for being here together with us, Moiya. And I'm going to hand the baton over to you to tell us about your new book. Thank you.
Thanks so much, Helen. You can't see him. Cosmo's actually right out there looking at me as I'm giving this talk. So today I'm going to be talking about the Milky Way, which is the galaxy we live in. It's the book that I just wrote, and I believe that thinking like or about the Milky Way also provides a much needed shift in perspective for us small-minded humans. So I'm going to be telling you a bit about that today. But first, I want to start with a quote from the book. This is actually the first paragraph of the book, and it says, "Take a look around you, human. What do you see? That book you're holding isn't just a book. Even the planet your kind is on the brink of ruining isn't just a planet. They're all me. Everything you've ever seen or touched is a part of me. Yes, even you vain, filthy animal." So this is the opening salvo to The Milky Way, an autobiography of our galaxy. This book is about the Milky Way. It tells the story of its creation all the way through to its eventual demise when the universe ends, but it's all told from the perspective of the galaxy. And that was a really valuable experience for me, thinking like I was the galaxy for the last 2 years. I did get the deal to write this book literally a week before lockdown started in New York for the pandemic. So I wrote this line in May of 2020, a time when I felt probably more disconnected from everything and everyone than I had ever felt before. But flash forward to 2 years later, now looking back at this quote, I feel more connected to myself, to my friends, to nature, to the universe than I ever thought I would. So I want to help you develop some of those connections. I want to teach you about the connections that our ancestors have felt with space. There are so many different ways to connect to the cosmos, but all of them require looking back in time. So let's start at the very beginning of the universe. According to our modern scientific understanding of the universe that we live in, everything started about 13.8 billion years ago with what we call the Big Bang. The Big Bang is not an explosion, and it did not happen in one place. Instead, it was the creation of our universe that started in an infinitesimally small point. So because the entire universe was in this one tiny point, the Big Bang technically happened everywhere. And we can indeed see signals of the Big Bang, heat signature left over after the Big Bang, everywhere we look out in space. Immediately following the Big Bang, and I'm talking less than a fraction of a second after that event, the universe inflated. We call this the inflationary epoch. And this tiny speck of universe inflated to thousands of times its original size in less than a second. This concept of inflation is kind of in debate right now. We're trying to figure out if it's actually what happened, but thankfully we have new data coming in all the time, and hopefully if I keep doing talks like this in a year, I'll be able to say with more certainty whether or not inflation was real. But we do have a much better understanding of what happened in the universe long after the Big Bang. And when I say long, I mean the formation of the first atoms about 400,000 years after the Big Bang. That's how long it took for the universe to cool down enough for these particles, the protons, the neutrons, and the electrons, to stop whizzing around, passing each other because they were too hot and too energetic to stick together. So it took about 400,000 years for those first atoms to form. And it was around that same time that light started to escape so that we can actually see what happened at that point in the universe. Astronomers, when we're looking back through space, when we're looking really far away, we're actually looking back through time because it takes time for light to travel to us. So there is actually a point we are looking back at the universe where it starts to look dark because it was too hot and photons, these particles of light, were trapped inside, so we couldn't see anything that was happening. About 400 million years after the Big Bang, the first stars started to form and the first planets started to form around them. All of these stars were mostly made of hydrogen and helium. Those are the two elements that existed right at the beginning of the universe. And that means that those stars were really big, they were massive, and they were extremely hot. They probably didn't live for very long, only about 10 to 100 million years or so. And I know that sounds like a long time to us humans, but to space, to the Milky Way galaxy, that actually is a very long time. Stars were born, and then galaxies started to form. Galaxies are collections of stars, gas, dust, dark matter that need time to come together under the force of gravity to create the giant swirling masses of stuff that we see and study today. And then it just took billions of years of stars being formed, stars going through their evolutionary cycles and dying. When massive stars die, they take the heavy elements that they form in their cores, all of the carbon and the nitrogen and the oxygen, but even things lighter than that, like lithium and beryllium. All of those elements get flung out into the universe when the most massive stars die. I am, of course, talking about supernova explosions, some of the most energetic and exciting events to happen in space. But that happens over billions of years with stars seeding the galaxy around them with heavier and heavier elements until eventually you get enough carbon and nitrogen and stuff to form Earth. And now, after 13 plus billion years, we have taken the magical stuff that the universe has provided and turned it into almond milk because we're humans and we can do that. And I think that's beautiful. So that's the story of the universe, the story of how we came to be here today. But I want to talk more about our ancestors' connection to the universe. We are all connected to space because we are literally made of space. Carl Sagan said that humans, that we are all made of star stuff. That is absolutely true. We are made of very material that stars created in their core and then kind of vomited it out into space to make us. But that leftover star vomit that eventually turned into humans started to look up pretty early in our evolutionary history to develop a relationship with space. So many cultures around the world put their gods, their origins, and their afterlives among the stars. This illustration is representing a Mayan myth about their afterlife and how you get to their afterlife by passing through a rift in the Milky Way. They have their jaguar god who crawls through this dark space in the swath of light that the Milky Way casts across our sky, and that is how they get to their afterlife. There are also so many cultures that imagined an actual interplay between space and human behavior, that we could influence what happened up in the heavens. This illustration you see on the right is representing one of my favorite Milky Way creation myths. It comes from the Khoisan people in southern Africa, and that story says that at first there were no lights in the sky. It was completely dark and you couldn't see anything at night, but there was this young girl dancing around a fire at night until she got hungry, because dancing is hard work, you burn a lot of calories, and she needed to get home to have dinner with her mom, but didn't know how to find her way back to her house. So she took some embers from this fire and she flung them up into the sky, and those embers created the path of the Milky Way that we can see. There are different versions of both of these myths, so if you've heard something similar to that but not exactly the same, maybe you've just heard a different version. Both of these illustrations, by the way, are by Anna Marie Salai. They are two of the illustrations that you can find in this book. They're gorgeous, and I think that you'd like seeing the other ones too. But ancient humans didn't just look to the sky to answer these fundamental questions of where we came from and where we're going next. They also used the night sky for extremely practical things, like keeping time. We didn't have calendars, we didn't have stopwatches thousands of years ago. Instead, we had the regular and periodic motion of stars, planets, the moon, and the sun across the sky. There's one example that I really love of ancient Egyptians using the Sirius star. This is one of the brightest stars in the sky, although they called it the dog star or Isis. When this bright star appears above the horizon in the morning, actually around this time every year in late summer, that would happen to coincide with the time of year that the Nile River would have its annual flood. The flood itself was pretty dangerous. It could wipe people's homes away, but it also nourished the soil so that they could grow their crops for the next year. So the Sirius star coming over the horizon in the morning served as a reminder that this dangerous but life-giving flood was about to happen. They also absolutely used space to navigate. There are still people today, sailors, and people who follow old traditions who know how to navigate by the stars. Polynesian wayfarers traveled thousands of square miles around the ocean using the stars long before there were compasses. And I know that some of my ancestors, some enslaved Africans in the early United States, used the stars to come to the north to escape slavery and find their freedom. Ancient humans have also used the stars to make cultural connections and to establish cultural identities. They told stories about constellations, and you could talk to someone and kind of determine if they were familiar to you, if they were one of your kin, by seeing what they called different constellations and asterisms in the sky. So those are some early human connections, but we are still connecting with space in the modern day, although most of the time these days we are doing that through telescopes. We have built telescopes that serve here on Earth. We have sent telescopes out into space to study the deepest parts of the universe that we would never be able to see with our own eyes. But most humans don't connect with space that way. Instead, a lot of people find space through astrology, which, as I just mentioned, had very practical roots in seeing how the motion of things across the sky influenced your everyday life. And today, there are 70 million Americans who read their horoscopes every day. And that's just in America. I know that astrology is alive and well in other parts of the world. There are also so many people who connect to space through fashion and through technology. I have literally lost count of the number of NASA sweatshirts and t-shirts that I see walking down the streets of New York City. And actually, I do have a question for you, audience. I won't be able to see you, but I would love you to type into the chat, what your preferred NASA logo is. This logo on the left is called the NASA worm, and the logo on the right is called the NASA meatball. And astronomers do have a pretty heated debate about which one is better. So I would love to know what you think. Please type in the chat. Are you more a NASA worm person or a NASA meatball person? And I will tell you my preference at the end of the talk. So this is one of the only ways that we're able to connect with space these days, because so much of the night sky has been taken away from us. The Dark Sky Association, which is this nonprofit that protects different dark sky zones around the world, has estimated that 4/5 of the night sky is affected by pollution. That's both light pollution and air pollution, because smog and other gases in the atmosphere affect the way that we can see those twinkly starlights. So this is modern connection to space. I also have my own way that I have connected to the Milky Way, and that is through my research that I did in grad school, where, as Helen said, I was selected as a National Science Foundation Research Fellow. My research looked at the habitability of planets outside of our solar system. We call those exoplanets. It also looked at the motion of stars around the galaxy, stars that are moving on circular orbits out here in the disk, stars that are moving on more chaotic orbits closer to the center of the galaxy. I love them all, though I do think that stars in the center of the galaxy are more interesting. And when you take these two pieces of information and put them together, habitability of planets and the motion of stars, what you get is information about the galactic habitable zone. This was my big thesis, my big dissertation when I got my PhD. I was constraining the galactic habitable zone. In other words, I was asking, if there are aliens out there in the Milky Way, where do we expect them to be? And I answered this in a few different ways. I'm going to tell you about one of my research projects, but first I need to tell you about the anatomy of the Milky Way. What does its body look like? And actually, there is a chapter in this book called My Body, where the Milky Way talks about this, but I'll give you a brief rundown. So here on the left, you see a face-on view of the Milky Way. You can see those gorgeous spiral arms. You can see where our solar system is, about halfway between the center and the edge of the disk. But on the right, you see an edge-on view of the Milky Way. Neither one of these are pictures, by the way. We've never taken an actual photograph of the entire Milky Way galaxy, because no human-made object has ever left the Milky Way galaxy to then turn around and take a picture. But I love this side view because you can see the different components. You can see the disk with the sun in it. In the middle, you see the bulge. This is a more spherical region of chaotic stellar motion. Outside of the disk, you see this big bubble that we call the dark matter halo. And in that dark matter halo, you can see these little specks. Those are clusters of stars that we call globular clusters. And a lot of those are actually left over from interactions between the Milky Way and smaller galaxies that it ate many billions of years ago. So that's the anatomy of the Milky Way. This project that I had a great time doing in grad school looked at the motion of stars in the bulge, so in that central spherical region. I simulated the orbits of millions of stars in this region of the galaxy to see how often they would come into close contact with each other. So this graph, I'll explain it, is what's called a cumulative distribution function. I know that this is Google, so you're all very smart and you're all very tech-oriented, but just in case anyone's confused, this graph is showing the fraction of stars that would have encounters within a certain distance and how many encounters they have. So let's pay attention just to this yellow line. This yellow line is for encounters within 1,000 astronomical units. For reference, 1 astronomical unit is the distance between the sun and Earth. If something came within 1,000 astronomical units of the sun, it would technically be in our solar system. So this yellow line is showing you the fraction of stars that have those close encounters. How many stars in the bulge have other stars coming like inside of their systems? And what I found in this whole simulation process was that most stars, 80% of them, have one of these close encounters, and half of them have dozens of close encounters within 1,000 AU. Of course, for encounters within 100 AU or within 10 AU, these even closer encounters, those are less common. But an encounter within 1,000 AU could definitely interrupt planets' orbits. It could rip a planet away from its host star. And if it happens early enough, it could actually interrupt the planet formation process altogether. So I loved this project. It showed me that if we are looking for aliens like us that need planets that have stable orbits around their stars, we're probably not going to find them in the bulge of the Milky Way. So I just wanted to share that with you because I'm a nerd and I'm very proud of this research. And it's also my only research project that explicitly made it into the book. I do want to talk a bit about how I wrote this book. What was it like to channel the Milky Way galaxy and really get inside its head and start thinking like a sentient galaxy for the last couple of years? One thing that I really had to do while I was writing this book was push beyond my own human perspective, think outside of my brain, I actually spent a lot of time with my eyes closed, imagining that I was not standing on Earth, but that I was the whole galaxy looking at our tiny little pale blue dot. That was a really valuable exercise in writing, like so that I could write the book, but also to shift my perspective as a person. But I did let the science guide me through a lot of my decisions when I was writing this book. One question that I keep getting as I go on this press run for the book is, how did you decide the personality for the Milky Way? Which I write as a very sassy, confident, some people call it jerky personality. And it was inspired by the science. The galaxy is more than 10 billion years old. For most of that time, it's been really lonely. It spent all of its time creating stars, but then feeling guilty that those stars inevitably have to die for the galaxy to continue in its current form. So it feels terrible about that. It feels really guilty, but it also knows that it's the biggest, strongest galaxy in its little neighborhood of about 50 or so galaxies that we call a local group. That combination of feeling really guilty, but also feeling superior, just to me, it made sense that it would be very sassy. It would have a chip on its shoulder. Another way that I let the science inspire this weird narrative nonfiction project of mine was in the relationship that the Milky Way has with other galaxies. Like I said, there are about 50 galaxies in our local neighborhood, and most of them are much smaller than the Milky Way. They are small dwarf satellite galaxies that orbit the larger galaxies in the group, like the Milky Way and Andromeda. There are two that get most of the mentions in this book, the Large and Small Magellanic Clouds. I would love yet another opportunity to type in the chat if you'd like. I would love to know if any of you have ever seen the Large and Small Magellanic Clouds. You can see them with your naked eye. I went to Hawaii when I was a senior in college and saw the Large and Small Magellanic Clouds for the first time. They were gorgeous, and I would love to know if any of you have had that experience. But the Milky Way sees those small dwarf galaxies less as friends and more as pests, as annoying hoverers who just bother it all the time. And so that made sense to me because of the way that big galaxies interact with small galaxies. And also, if you pick up this book, which I hope you do, you'll see that black holes are used as kind of a metaphor for mental health struggles. Black holes in this book are the physical embodiment of everything that a galaxy hates about itself. It's that little voice in the back of your head saying to the Milky Way galaxy, you suck, you are an awful friend, you're an awful galaxy, you're never going to amount to anything. I have often heard depression and anxiety be referred to as a black hole, as something that sucks you down and makes it harder for you to get up. So I loved expanding that metaphor in this book. I also had to learn to be extremely confident when I was writing this book because the Milky Way is. And I mentioned my cat Cosmo at the beginning. A lot of what I drew inspiration from for this book was Cosmo, was looking at my cat and seeing the utter disinterest that he has in me, even though he's so dependent on me for his survival. And of course, a writing fort was a must when I was writing this book. I spent so much time under that blanket, just trying to get rid of any earthly distractions that could get me out of the mindset of the Milky Way galaxy. That's a bit about how I wrote the book. I want to share with you some of the shifts in perspective that I noticed I have after writing this book, and I think that they'd be really helpful for other people too. And what better way to talk about this shift in perspective from thinking like a galaxy than with the galaxy brain meme. So the first real big lesson that I learned was that zooming out in both time and space, so thinking about the universe as something that is almost 14 billion years old and billions of light years across, thinking on those scales made my earthly human problems seem really small. When you are thinking like a galaxy, who cares if you gain a little weight? Who cares if you get a B on a test? Who cares if the person you flirted with at the bar a couple days ago doesn't text you back? Those things don't matter to galaxies. And I know they matter to us in the moment, but if we could just learn to zoom out, then we would let those small problems fall through the cracks. The second thing I learned was that people really respond to something that you are authentically excited about, even if you think it's weird. When I first started proposing this book, I was nervous about this angle of writing it from the Milky Way's perspective. And indeed, I did get a few editors who thought that the idea was too childish and that it wouldn't work for adult audiences. But by and large, the response I've gotten has been incredibly positive. Oh my God, this is so unique. Oh, wow, it's so interesting that you did it from this perspective. I've never seen anything like that before. And even though I was worried and I thought it'd be super weird, people seem to be very into it. So live your weird, authentic, freaky life, and you will find people who welcome that and support you in it. And finally, I learned that there is way more than one way to know or understand something. Throughout history, humans have understood the universe through mythology and through mathematics. We can understand ourselves by thinking about the different personalities we have, and that doesn't have to be a disorder. It can be a really positive acceptance of the fact that no person, no individual is just one type of person. So I encourage you to try and see things from different angles, from different perspectives, and know that just because you're seeing it from a different perspective doesn't make the other one wrong. And I have just a couple more minutes, so I would love to, first of all, thank you for listening to me ramble about space and the Milky Way for 30 minutes. But I also would like to invite you to take into your life some of my other work. So there's obviously this book. You can find it anywhere books are sold. There's also an audiobook that I narrated so you can hear me speaking into your ears as if I'm the Milky Way galaxy. I also co-host a show on PBS YouTube, PBS Digital Studios called Fate and Fabled. And it's all about mythology from around the world. We've done episodes on Aztec or Nahua mythology. We did an episode about the Greek fates. I have even done an episode about the constellations and another episode about sun myths, which is very exciting. And one of my favorite ways to combine my two sets of expertise is through my podcast Exolore, which is actually a portmanteau of exoplanet and folklore. It's a world building podcast. Sometimes I build a brand new fictional world from scratch. Sometimes I interview other world builders, and sometimes I analyze fictional worlds that have already been built. There are more than 50 episodes that you can catch up on. You can find those wherever you get your podcasts. So I'm coming in right under time. Thank you so much for listening to me. Please check out my other work. You can find me on social at GoAstroMo. And yeah, now I want to know what you want to know. If you have any questions, what was unclear, let's chat about it.
All right. Well, thank you so much, Moiya. That was awesome. And I want to strongly encourage people to read the book. I got an advanced copy early, and you're sort of the opening salvo and the sassiness of the galaxy just comes through the whole thing, but in such a humorous and engaging way. So I'm really enjoying it. So thank you so much. Strongly encourage others to get the book. I had a whole list of questions that I was going to dive into, but it sounds like we've already got lots of great audience questions. So I'm just going to ask one of my questions, and then we're going to bring those audience questions up. I think it'll be great for everybody to just hear a little bit more about yourself and sort of early influences, and particularly what sparked your interest in folklore and space, because on the face of it, they seem like two such disparate things. You've obviously brought them together in some of what you just shared with us, but was there one particular moment that clicked for you and set you on your path? And like, how did you end up studying this combination of astrophysics and mythology that obviously ultimately led you to this book?
Yes, of course. I'm afraid the answer won't be very satisfying, but I'll let you know the secret anyway. So I grew up in a log cabin in the middle of the woods, and I remember telling my friends in college that I grew up in a log cabin, and they pictured like a beautiful Vermont ski lodge. No, this was like a Lincoln log cabin built in the early 1800s that was falling apart and didn't have running water, and the only way we could heat it was with our fireplace. So it was a very strange way to grow up in the early 2000s, but I used that weird upbringing and the strong imagination that I had to develop when I was living there to get me out of my hometown, essentially. I went to Harvard for undergrad and didn't know what I wanted to study. I was bouncing around trying out different fields when one of my friends dragged me to an astronomy course, and the professor said we'd get free pizza every week. So I signed up, and by the end of the semester, I was in love. And on the folklore side, I had always been interested in mythology and folklore, but didn't realize you could study it in school until my freshman dorm was literally across the street from the folklore building, and they always had like tea and cake and cookies for us to eat. So food is the reason that I decided to study both of these things, food and indecision.
Okay, and a lot of serendipity because you pulled it together in such an extraordinary way. Okay,
Exactly.
let's bring up our first audience question. All right, from Sophia. So thanks for coming today. Excited to read your book. What's one thing you want any reader to take away from your book?
Oh, thanks, Sophia. When I tell people I'm an astrophysicist, I often get a frightened reaction. There are a lot of people who are afraid of space because they think about how big it is and it makes them feel really small and insignificant. The Milky Way absolutely talks about that in the book. There's a passage where it says that you humans, you're so small and insignificant. It says it in a more you are insignificant. That means that every other human on Earth is just as insignificant as you. Even like the biggest celebrities, you mean as much as they do in the grand scheme of things. All of you humans are meaningless, so you should consider each other precious because you're all you have. I think I would like people to take that away from it, that you can think about the vastness of space without getting overwhelmed and instead let it be an encouraging thing.
I agree. And I feel like already with what I've been reading in the book, that comes through loud and clear. And that's definitely one of the takeaways I'm experiencing. So
good.
All right, let's bring up the next question. Stephen, so what's the one most important thing you think we'll learn about the universe in our lifetime?
I would love it if we would learn about the alien question, if we could confirm or deny the existence of aliens, but I don't think that'll happen in our lifetime. Instead, I think the biggest question we might be able to answer is, what is dark matter made of? There are theoretical and experimental physicists actively researching this question, and we have some good ideas of what it might be. I think we could answer that question in the next few decades.
I think humans have definitely historically had an obsession with is there life outside, and we
I know.
there's so many movies about it. I'm actually just reading Project Hail Mary to my husband, which again touches on this subject of aliens.
Well, awesome.
Next question from the audience. Let's bring another one up. Tony, so how does the concept of a year, so the amount of time it takes the Earth to make one rotation around the sun, translate when we talk about the Big Bang?
Yeah, a year is a totally arbitrary unit of time. um, Other planets, even in our solar system, they have different year lengths. On Venus, a day, the time it takes to rotate, is longer than a Venusian year, the amount of time it takes to go around the sun. So they are totally random units of measurement, but that doesn't mean that the quantity, that the value we get when we measure the age of the universe is wrong. That number, that absolute number, is, as far as we can tell with our data, correct. It is the amount of time that equates to 13.8 billion years. But we could measure that in Venusian years. We could measure that in like Usain Bolt's run times. Like, it doesn't matter what unit we use. The ultimate quantity is the same.
Thank you. All right, let's bring up another question from Michael. Are there any theories of what happened before the Big Bang, or what caused it to bang? Like, what triggered the expansion? I'm fascinated by this myself.
This is a great question, Michael. It's a question that even the most seasoned physicists have trouble wrapping their minds around. And I will say we don't have any real theories. We do have some hypotheses. A theory being something that has been rigorously tested and proven, not proven, but shown to be likely true over and over again. And a hypothesis is an idea that hasn't been proven yet. It's possible that every time a black hole forms, a new universe is created, and there's a new Big Bang on the other side of that black hole. That is a debatable hypothesis. But other than that, astronomers kind of shrug at the question of what happened before the Big Bang, because we don't have any data from before the Big Bang.
Okay, I'm gonna throw in a question. Like, why was it important to you as you were writing this to interweave sort of myths, legends, folklore with science? Like, what was the purpose of bringing these seemingly disconnected disciplines together?
Yeah, thank you. I wrote this book to teach people about the universe, but also to show them how our understanding of the universe has changed over time. And I think that I would be remiss, it would be irresponsible of me to talk about the evolution of human understanding of the universe and only talk about telescopes and the data that we can observe now. Because I see mythology as humankind's early attempt at science. These myths about the changing of the seasons and weather and eclipses, they didn't come out of nowhere. They are based on real observations that early humans made of the world around them. And then they were trying to explain what happened given their current understanding of how the world works. So I had to include the myths. Otherwise, the book wouldn't tell people how far we've come. And one of the things that the Milky Way admires so much about humans, one of the few things that the Milky Way admires about humans, is how far we have come in getting to know more about it.
Do you have, I know you shared a couple of sort of myths with those images, but do you have one particular one in mind that you think is closest to the reality of what actually happened? Because it's quite extraordinary. Before we had the science, before we had telescope, you made a comment that I read in your book that it's surprising actually in some ways how accurate we were, having none of the science available to us, and yet we were still able to sort of hypothesize what could have happened without knowing that it was much closer to fact than we could possibly have known at the time.
Yeah. Actually, a lot of creation myths from around the world are pretty similar. So I'm right now thinking of the Greek and Norse cosmology myths or creation myths. And in those, you can see that the universe started with chaos or with darkness or nothing, and then from it sprung. Actually, I'll talk about the Greek one first. The universe started with chaos, and then from that sprung Gaia, which is the personification of the earth. Gaia then created Oranos, which is the personification of the sky. And together they created every other living thing here on Earth. And if you think about that, that sounds very similar to the universe being a mostly dark, chaotic place. The Earth forms, and then the atmosphere forms on top of that, and then the interplay between the atmosphere and the Earth creates humans. And you can see that really beautifully. I think also in the Norse creation myth, they talk about how there are 9 worlds in Norse mythology. All of them are connected by Yggdrasil, the great tree of life. And the 2 most extreme worlds are a world of ice and a world of fire, and Midgard, where humans are, that exists in between them, where the ice and the fire melt. And of course, it's the Norse people who are living in Norway and Iceland, a place with volcanoes and glaciers. Of course, they can see the way that fire and ice come together to make liquid water. This myth, to me, is very reminiscent of habitable zone calculations in astronomy. When we look for a habitable planet, we are trying to find a world that is the right distance from its star to have liquid water. So you can see this in so many myths. I couldn't pick just one.
That's so true. All right, let's bring up some more audience questions. Andre, so hi, I'm excited to attend such a talk. I heard that Gaia measured position/velocity of millions of stars, and we got an understanding of 25% of the Milky Way. When do we expect to cover 100%?
I love Gaia. I used Gaia data for a couple of my research projects in grad school. Gaia looked at you're right, positions and velocities of stars in the Milky Way and gave us the most accurate map of stars in the galaxy that we've ever seen. I think 25 is a little generous. I think it's given us like 10 to 20% of the stars in the Milky Way. We are probably not going to be able to see the other edge, the other side of the Milky Way galaxy. It is extremely difficult for us to see through all of the gas and dust that's collected in the center of the galaxy. Remember that anatomy image that I showed you? We're out here in the disk, and if we were to see through to the other side, we would have to see through all of that bulge that is extremely dense and bright and just covered in gas that it's hard to see through. So we probably won't get 100%. But one rule in astronomy is that things tend to be isotropic and homogeneous. So what we see on this side of the galaxy is probably very similar to what we see on what would be on the other side of the galaxy, even though we can't see it.
Got it. Thank you. Another question from the audience. Michael, so there used to be a theory of the big crunch, but I think now they say the universe is still expanding faster because of dark matter. What's the current thought on how things end?
Thanks, Michael. So I want to do a small correction. We say that the universe is expanding, and that could just be because of the energy left over from the Big Bang. And it's dark energy, not dark matter, that is responsible for speeding up that expansion. The universe would still be expanding even without dark energy. But now we have noticed that it's accelerating, and that is because of dark energy. If dark energy is very strong, then the universe can continue to expand forever. One potential scenario is that it expands until all of the energy in the universe is too distributed for there to be any movement or any heat. That's called the big freeze. Another option is that the expansion will continue to speed up, and it will get so strong that everything gets ripped apart, even galaxies, even stars, even individual atoms. The big crunch is a scenario where dark energy isn't that strong, and eventually the expansion will slow down, stop, and then come back in on itself. We have to learn a lot more about how dark energy behaves over long time scales and on big size scales before we know exactly what's going to happen. But most scientists right now, I think, would agree that the big freeze is the most realistic scenario.
Okay, We're almost at time, but I think we've got time to squeeze in one last audience question. So let's bring that up. From Mike. Okay, how do you recommend inspiring future generations to look up and study the galaxy and long duration changes when they're so busy looking down at their phones and worried about the next 30 seconds?
Yeah.
Let's go through, Mike.
It's this. This is how I did it. The end of this book, not to give it too much away, but the Milky Way signs off by saying, when I started this project, all I wanted to do was inspire. So now that I'm done, you better be inspired and tell my stories. I think that if we can get more people thinking about space, thinking about our connection to it, maybe even getting more people into space, but without colonizing, like getting more people to see the various connections that we have to the cosmos would be powerful enough. Even if we stopped thinking of ourselves as separate from space, I think that would be enough for me, because Earth is a spaceship. We are traveling through space right now, and like I showed you with those emojis, like Carl Sagan said decades ago, we are star stuff. We are space. So let's stop thinking that we're separate from it.
I love that idea that we're made from stars. And with that, I think we're right at time. So let me share my heartfelt thanks on behalf of everybody who's listening today. We're so grateful for you to come and share your thoughts and perspectives. And I'm super excited for everybody to have a chance to read the book. So with that,
Thank you so
enormous
much.
thank you, Moiya, and have a wonderful day.
Thank you. You too.
Take care. Bye-bye.